Welcome everyone. I heartily welcome you to Math Simplified by HM channel. Today we are diving into very practical application of the Pythagoras theorem, specifically exploring how it behaves in acute angled triangles. We will walk through a formal step-by-step geometric proof to make this concept crystal clear. Before we begin, please like and share this video with your well-wishers and friends. Subscribe to the channel and click the bell icon to stay updated. Now grab a notebook, pause as needed, and let us get started. Application of Pythagoras theorem, acute angled triangle, a step-by-step geometric proof. The theorem statement, we read it carefully. In triangle ABC, angle C is an acute angle and segment AD perpendicular to sec BC. We have to prove that AB square is equal to BC square plus AC square minus 2BC into DC. Look into the diagram. This is a triangle ABC in which angle C is acute angle and segment AD is perpendicular to side BC, and we have to prove that AB square, the side opposite to C, is equal to BC square plus AC square minus 2 times BC into DC. Setting up the variables. Now for simplification, let AB is equal to C, AC is equal to B, and BC is equal to A. Let altitude AD is equal to P. Let DC is equal to X. Therefore, remaining segment BD is equal to A minus X. Now step 1 of proof. In triangle ADB, which is right angle as AD is perpendicular to BC. Therefore, in the right angle triangle ADB, applying the Pythagoras theorem, we get AB square, that means hypotenuse, AB square is equal to BD square plus AD square. Now substituting our defined variables, we get C square is equal to in bracket A minus X bracket square plus P square. Expanding the binomial A minus X bracket square, we get C square is equal to A square minus 2AX plus X square plus P square. Name this as equation 1. Now in the right angle triangle ADC, applying the Pythagoras theorem, hypotenuse AC square is equal to DC square plus AD square. Substituting our defined variables, we get B square is equal to X square plus P square. Rearranging to solve for P square, we get P square is equal to B square minus X square. Name this as equation 2. Steps 3. Algebraic substitution. Now substitute the value of P square from equation 2 into equation 1. Original equation 1 is C square is equal to A square minus 2AX plus X square plus P square. Substitution gives us C square is equal to A square minus 2AX plus X square plus in bracket B square minus X square, the value of P square from equation 2. Now X square get cancelled to each other and we get C square is equal to A square plus B square minus 2AX. Final conclusion. From our algebraic step, we have C square is equal to A square plus B square minus 2x. Substituting the original side lengths back in place of variables as C is equal to AB, A is equal to BC, B is equal to AC, and X is equal to DC, we get AB square is equal to BC square plus AC square minus 2BC into DC. Hence, we have proved the theorem statement clearly. To wrap our lesson, I want to remember a special formula, not just for geometry, but for your own lives. Your success formula is hard work square is equal to preparation square plus consistency square minus mistakes, where you actively minimize the mistakes like subtracting 2BC into DC. This means that just as minimize the subtractive term in our proof, actively minimizing mistakes leads to greatness. Thank you all for your wonderful attention today. Please like and share this video with your friends, colleagues and well-wishers. Don't forget to subscribe to Math Simplified by HM and click the bell icon to stay updated. Enjoy the great time ahead.